Hello everyone. In the last video we have seen the mathematical analysis for factorial of n numbers. So today we are just going with Tower of Hanoi. Before going for the mathematical analysis, we'll see how the Tower of Hanoi will work so that it will be easy for you to just take the general plan. So Tower of Hanoi means we'll be just having a tower and we'll be having a disk, a set of disks. For example, if we have some 4 disks, in this Tower of Hanoi we'll be having 3 disks. One is source, this is destination, and this is the temporary disk. From source to destination we have to just pass the disks. Okay, so means from source tower to destination tower we have to pass the disks. So here we have some set of rules. That means on top of the bigger disk only the smaller disk should be present. On top of smaller disk we cannot place any bigger disks. Okay, and then at a time only one disk has to be moved. So like that, if we follow that, and then we have to move the disks from source to destination. With respect to the code, actually here I am not showing you the step-by-step procedure. Here in general what we will do, first this n-1 disks will be just moved to temp. So in this temp we will be just having n-1 disk. n is equals to 4. n is the number of disk. n is equals to 4. We have taken n-1 means 3. 3 disks will be moved to temp. Then here only one disk will be left out. This one disk will be moved to destination. So the last disk has been moved. Next again I have to just move this disk to destination. So here also again I have to consider n-1. So again I'll just transfer these n-1 disks to source, because in source we don't have anything, is it not? So I'll just transfer this n-1 disk into source. If I transfer that, here only this will be left out, that will be transferred to destination. Next, in source you don't consider this. I'll be having only 2 disks here, because from here I have just moved n-1 disk. This will become n-1. This one again I'll just transfer to temp, and this disk will be moved to destination. And then from temp only one disk will be present in temp, that will be moved to destination. This is how we are just moving it, is it not? So from source to temp, temp to source, how many disks we are moving? Each and every time we are moving n-1 disks, is it not? So here while writing the general plan, it should be like, from source I am moving n-1 disks always. From temp also to source I am moving always n-1 disk. But to destination, how many disks we are moving? At a time we are moving only one disk. So this should be equal to 1. From source to temp I am moving n-1 always. From temp to source also I am moving n-1 always. And from temp and source I am just moving to destination always the only one disk. So I am just moving only one disk, so it is plus 1. This is the general form. This one in the generalized form I can just write it as 2 into m of n-1 plus 1. m of n is equals to 2m n-1 plus 1. This is how I can just write, is it not? So while writing the general plan, what is the initial condition here? Initial condition, if only one disk is present, then m of n is equals to, means it is only 1 for n is equals to 1. That means if only one disk is present means you will be having only one move. So this is the initial condition for n greater than 1. For n greater than 1. If it is 2 disk, 3 disk or 4 disk, then the general formula is this one, 2m n-1 plus 1. This is the general plan for Tower of Hanoi. So next we'll move for the mathematical analysis. This is how we will just take the general plan. Okay. So now we'll just move for the mathematical analysis. So this is the initial condition, 2m into n minus 1 plus 1. This is the initial condition we have. With this one, we'll start the mathematical analysis. As I have just told here, in the last video, I have just showed you this 2 is a constant, this 1 is a constant, m of n minus 1 is the function. Yes, here we have 3 different parts. 2 is a constant, 1 is a constant, m of n minus 1 is the function. Yes, always we have to just keep the constant as it is. Whenever I encounter the function, it has to be replaced with the entire thing. Yes, so I'll just show you the first step. 2 is the constant, I'll keep 2 as it is. Then I'm encountering the function m of n minus 1. So here, in place of m of n minus 1, and before that, replace n by n minus 1. Inside the function, what is the parameter we have? That is n minus 1. Inside the function, we have n minus 1. So replace n by n minus 1 in each step. m of n minus 1 this is it not? So next, 2 of 2 into m of n minus 1 minus 1 plus 1. For this function, I have replaced this entire thing. 2m, replace n by n minus 1. m of n minus 1 plus 1. Next, third part is the constant, plus 1. Again, I'll just keep this plus 1 as it is. Yes. So this one, how can I just write? 2 into 2. That is 4m into n minus 2 plus 2 into 1, 2 plus this constant 1. I'll keep as it is. Yes. Next, this here 4 is constant. I'll keep 4 as it is. In place of m of n minus 2, I have to replace this entire thing. 2 m of n minus 1 minus 2, because in each step you have to replace n by n minus 1. Yes, plus 1, this entire thing. Then 2 is constant, 1 is constant, plus 2 plus 1. I'll keep as it is. This step, 4 2s are 8m into n minus 3 plus 4 into 1, 4 plus 2 plus 1. Yes. Next, 8 is constant. I'll keep as it is. In place of m of n minus 3, I'll replace the entire thing. 2 into m of n minus 1 minus 3 plus 1 plus 4 plus 2 plus 1. These are constant. I'll keep as it is. This will become 8 2s are 16, m of n minus 4 plus 8 plus 4 plus 2 plus 1. You can just see here it is 2. This one I can write it as 2 power 1. This is 4. I can write it as 2 square. This is 8. I can just write it as 2 cube. This is 16. I can just write it as 2 power 4. Is it not? So even here also, this one I can just write 2 power 0, 2 power 1, 2 power 2, 2 power 3. I'll just write as 2 power 4 m of n minus 4 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. Next step, if I'm just writing, what will get? 2 power 5 m of n minus 5 plus 2 power 4 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. This is how I'll get. Is it not? So, like this, if I'm keep on doing all these things, what I'll get? Here for everything, if you take n, then there will be a confusion. So I'm just going with another term, that is I. 2 power I, because see, 2 power 1, 2, 3, 4, 5, like that it is going till I it will go. So I'll just write it as I. M of n minus, even here also first it was n minus 1, then n minus 2, 3, 4, 5, likewise it is going. I'll write in general n of n minus I plus this one. How can I just write 2 power 0? How can I just write this one? I can just write it as 1. 2 power 2 is 2 plus, if I just keep on going like that, 2 power I minus 2 plus 2 power I minus 1. This is how it will go, is it not? From 0 to I minus 1, because 0, 1, 2, 3, 4, then 5, 6, like that it will be going. So 0 to I minus 1. It will go till 0 to I minus 1. By seeing this one, easily we can say this is giving you the geometric series. This is giving you the geometric series. Do you remember geometric series? Rho is equals to a into r power n minus 1 divided by r minus 1. For this one, we have to apply this formula. A of r power n minus 1 divided by r minus 1. Yes, so here the difference is 2. So always it is 1. So a is equals to 1. 2 power I, that is r is equals to 2 and n is equals to I. Okay, if I apply that, 1, a is 1 into 2 power I minus 1 divided by 2 minus 1. 2 minus 1 is 1. Okay, only we need to solve this one. So here if I just take, I'll be 2 power I minus 1. For this entire thing, I can just have 2 power I minus 1. Here, what is the initial condition? M of n minus 1. Inside the function, I have a parameter n minus 1. So, here I can just take I is equals to n minus 1. If I take I is equals to n minus 1, then I can just write it as 2 power n minus 1 minus 1. Is it not? So, the same thing I'll just do here also. Replace I by n minus 1. This is 2 power n minus 1 m of n minus 1, because I have just replaced this one. So, m of n minus 1 plus this series, we just came to know that it is 2 power n minus 1 minus 1. Is it not? So this one, if I solve, 2 power n minus 1 m of n minus n plus 1 plus 2 power n minus 1 minus 1. Yes. So minus n plus 1 n will get cancelled. So I'll get 2 power n minus 1 into m of 1 plus 2 power n minus 1 minus 1. M of 1. You can just remember our initial condition. If n is equals to 1, then it should be equal to 1. So what happens? This will become 1. So I'll get 2 power n minus 1 plus 2 power n minus 1 minus 1. So here this one, 2 power n minus 1 plus 2 power n minus 1, I can just write it as 2 power n. Then this minus 1 is a constant. Okay. So here which is the order of growth? 2 power n, that is exponential. This is the order of growth. Okay. And here it will take so many things over here, because if it is only less discs, then it is fine, you can just have only few discs to transfer. But if you have hundreds of discs, then it is very difficult. So in this case, what we'll do is we'll consider this as the worst case. So I'll just write it as T of n belongs to big O of 2 power n. So the time complexity of this Tower of Hanoi, I'll just write it as T of n belongs to big O of 2 power n. So this is the time complexity of Tower of Hanoi. Okay, yes. So this is the mathematical analysis. In mathematical analysis, we have to keep in mind that we will be getting geometric series, we will be getting the arithmetic progression, all those things. You must remember all those things and then you have to just perform. Otherwise, this is very difficult to calculate if we keep it like this. If you know whether it is geometric process series or arithmetic series, then I can just solve it and then I can just perform the things. Okay, this is how I'll just perform the mathematical analysis. Okay, thank you.